Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to my fellow panels. I am RAZALI bin HASSAN and Associate Professor TS Dr. Nur Hafiz bin Muhammad Nur. I hope everyone stays safe during this pandemic time. My name is Nur AMALINA AIMIE binti DZULKEFLY and I'm from College of Engineering, School of Mechanical Engineering, University Technology Mara, UiTM Shah Alam. I am under the supervision of Professor MADYA AHMAD KAMIL HUSSAIN. The purpose of this video is to present my research, which is optimization of space thrust. Introduction. What is meant by a space thrust? A space thrust is a simple three-dimensional 3D that is made of slender members which are connected at joints and can be approximated to pin connections. Usually for thrust design, the compressive and tensile forces will act opposite on each member and causing less material to be used and increase in economic revenue. There is a few assumptions that need to be made when a structure is considered a truss. The first one is all the joints in the structure can be represented by a pin connection, which means the members are free to rotate at the joints. The second one, loads are only applied at the joint of the truss. There will be no loads acting in the middle of the members. This is because all joints cannot carry bending moment but can only carry axial loads. Each member has to be equilibrium so that the forces acting each of the end of the member equal and opposite. For structural engineering, it is important to know the development of the optimization concept and techniques. This development is important to make less cost but still efficient. The optimization technique must consider the design variables as a discrete quantities. There are many other methods in recent studies such as various mathematical formulas, linear extended interleaved penalty function, multi-class teaching learning-based optimization, particle swarm optimization, and many more. And most of the methods use continuous design variables, but in the practical life, the design variables are discrete. For this research, the method that used for optimization is the genetic algorithm. A genetic algorithm is a search heuristic that mimics the process of natural selection. It represents modern optimization techniques and is inspired by biological evolution, which adapts concepts like chromosomes, genes, natural selection, crossover combination of mutation. This genetic algorithm will be started by randomly generating a population of candidates inside the design space, and in this case is a limiting factor. Then the population is iterated in a loop, and each loop gives birth to a new generation of individuals to evolve towards the optimal solution. The optimal value is done when the percentage weight of saving of the total mass of the space thrust structure has been calculated. In the figure below shows the basic flow process using the genetic algorithm optimization method. The purpose of this study is to investigate a space thrust to obtain optimal thrust configuration which has minimum weight but still can avoid the failure. The objective in this research are to utilize the built-in solvers in MATLAB, to perform genetic algorithm optimization, to identify critical members in the space thrust based on design criteria such as displacement and stresses. And the last one is to determine optimum thrust configuration in the space thrust. The finding of this research is the percentage weight saving of space thrust using the genetic algorithm optimization method. Scope and limitation of the project. This study will be analyze one case study of the space thrust with 9 members and 5 nodes. Only one set of the loadings and one set of the supports condition will be considered. Methodology. The methodology of this research starts with manual calculation of 9 member space thrust followed by modeling in ANSYS software, then the material properties, the limiting factor, And the last one is genetic algorithm optimization. To understand better the analysis of space thrust, we perform the manual calculation to determine the support reactions and also the force in each member using a static equilibrium equation. There will be two loads will be applied at joint A, which is the first load is negative 100 kilonewton at Y direction, and another one is 60 kilonewton at Z direction. At the truss, there will be a roller supported at C, and roller slotted at E, and ball and socket at D. The reaction forces were calculated. This manual calculation was done to get a better understanding about the analysis in the space thrust. The force in each member were also calculated by identifying the zero force member, then using the methods of joints, which involves applying the equilibrium equations to solve the internal forces acting on every joint within the truss. The modeling was done using ANSYS Workbench 2021 R1 and ANSYS Mechanical APDL 2021 R1 by setting up the 9 members of a space thrust and adding the feed support at node 3 and roller support at node 5. Two forces act at joint 1. The figure below shows the basic structure of 9 members of the space thrust with 5 nodes. A model of a space thrust has been shown in represent the local coordinate x, y, and z, which have 5 nodes. All the nodes are critical to evaluate because when we run the optimization in the MATLAB, the coordinate of each node need to include as well as the displacement and the limiting factors. Using ANSYS Workbench 2021 R1, the mesh modeling with the course 0.002 with the radius of each member 0.004 was shown in this figure. Meshing is important in order to get the accurate result when running the ANSYS solver from the FEA model, while in this case is 9-member space thrust. The next figure shows the constraints that are put for the space thrust model, and the length of each member was listed in the table 3. The design parameter of the 9-member thrust structure was listed in the table 4. The space thrust element is made up of aluminium alloy, and the cross section is 5.0265 times 10 to the power of negative 5 meter square. The volume is 4.429 meter cube. The modulus elasticity is 69 gigapascal. The weight of the space thrust is 34,736 kilogram. The radius of members is 0.004 meter. The density is 2,770 kilogram per meter cube. The Poisson ratio is 0.33. It was assumed that all members have the same material and have the same cross section. There will be a limiting factor for this space thrust. The maximum allowable stress was taken is 375 megapascal, as it was assumed to be an aluminium alloy, and the maximum displacement constraints are already set for node 3 and 5 was 100 millimeter, and the safety factor is 2. All these criteria are the limiting factor for this optimization. Genetic algorithms are a subgroup of evolutionary algorithms or evolutionary computing. They are used in self-learning machine learning algorithms and AI. It uses the concept of natural selection to simulate the survival of the fittest and natural selection inside the computer. The genetic algorithm combines a Darwinian survival of the fittest procedure with a structure and information exchange so that it is capable of addressing a major spectrum problem. After running the solution in the ANSYS software, the next optimization procedure is to use the MATLAB toolbox to run the genetic algorithm. This can be done by using a data from the ANSYS command and transfer into the MATLAB. After the modeling was done in ANSYS Workbench 2021 R1, the solution of a total deformation, force reaction, maximum and minimum stress was computed. The maximum deformation happened at node 1, which is 0.002 to 483 meter, and the minimum at the center of the bottom of the space thrust. The maximum equivalent for missile stress also happened at node 1, where there are two forces acting on it. The length and the cross-sectional areas of member 5, 6, 7, 8, and 9 found to be shorter and slender after the optimization process. These members were not the main members in the truss that supporting the load. Hence, they will not significantly weaken the overall structure after the reduction of their size have taken place. These members occupy the base of the truss structure. However, since members 1, 2, 3, and 4 were the main carrying load, their size will decrease by a relatively small amount. This can be shown in both of these figures. In genetic algorithm optimization, the weight of the structure was minimized along with the cross-sectional areas of the members that were capable to carry the load before reaching their limiting strength. The optimization was done using a MATLAB R2021V. After 20 iterations, the original weight of the space thrust of 34,736 was reduced to 12,000 kilograms. There is nearly around 65% of the weight saving. At optimum condition, the lengths of members 5, 6, 7, 8, and 9 were found also reduced to a lower limit. At optimum, the height of nodes 2 and 4 was almost reduced to the lowest, and the area was reduced to minimum allowable. From this graph, the average weight of the space thrust design is 40,005 kilograms. And the member 1 is critical from a stress point of view, as the stress was close to the maximum limit. This is due to the member carrying the most of the load. The iteration stopped at 20 after the design has converged, and in this case, the strength and displacement were formulated as a limiting factor. The conclusion for the research is the 9-bar space thrust structure has been success to use as the case study in the optimization procedure. The genetic algorithm using MATLAB had been developed, and also the optimization result had been reported in this paper. The filling element analysis was utilized using ANSYS to obtain the thrust structural responses and the critical forces members. All the objective was achieved, and one of these is the optimization to minimize the weight of the space thrust but still meet the design requirement. The weight saving are nearly around 65% after 20 iterations. The iteration process could be concluded after 5 or 6 to save the computational cost. Overall, the method of genetic algorithm can be used to optimize space thrust, and the method is well suited for structural optimization since it can handle the discrete variables efficiently. The ability of GAs make this method as a good choice for optimization problems, as the optimal solution generated will be feasible from a both mathematical and a practical point of view. This optimization is very important to reduce costs and sustainability considerations. That's all from me. Thank you so much for your attention. If there is any question, you can email me or you can contact using my phone number 011-2885-2434. Have a good day and stay safe.